end up at negative x, y. That's symmetric to the y-axis. It's like you're using the y-axis as a line of reflection, if you will, if we want to talk about it in terms of reflection, which was very happy with the way that Nichelle began that. She was just answering the next question was all, right? So that's an even function. The one that we want you to kind of keep in mind is like a base case, if you will. F of x equals x squared. Now, this is going to be one of our key parent functions. As we get moving here, actually tomorrow, we're going to be talking more and more about parent functions. But we can essentially prove it. I mean, lack of a better term, we could prove it. So let's let x equal something. Let's stay away from 0 and 1. But I don't know. Oh, and what number should we use? 3. So if we put a 3 in place, that means that we want to evaluate f of 3. So that means that we're going to put 3 in place. We're going to go 3 squared. Do we all agree that we get 9? Yeah. Now what's it going to look like when I plug in the opposite of 3? Or I guess what I'm asking you, what is the opposite of 3? Negative 3. So could we find f of negative 3? All that we're doing now is putting a negative 3 in place. Negative 3 squared, we also get 9. Now, again, as we're talking about the quadratic parent function there, nobody's surprised by this, but you'll notice when I put 3 in place, we got 9. Negative 3 in place, we still get 9. So it didn't matter when I put opposite values in, I got the exact same thing back because this is an even function. Okay? Now an odd function, as we read through, it says that an odd function, it's going to be a function y equals f of x is odd if f of negative x is equal to the negative f of x. So what that means, remember in math, that negative sign really just means opposites. So now when I put opposite values in, remember if I put x in place, I got f of x back, just normal ordinary f of x. But if I'm putting negative x in place, now I'm getting negative f of x. So that means now my outputs are going to be opposites. Do we get that? Do we understand that? So if I put opposite values in, I get opposite values back out. That's an odd function. Okay? In terms of the symmetry, in terms of the graph, odd functions are going to be symmetric with respect to the origin. Now we're thinking about that line y equals x. We're thinking about your rotational symmetry to the origin, all of that good stuff. That's what we're talking about there. The base that I would like for you to be thinking about is the cubic function, f of x equals x cubed. This is your most basic odd function that we want you to think about. Let's use 2 this time. Let's go simple numbers. All right, so if we were to evaluate f of 2, that means that we're going to find 2 cubed. With your help, what's 2 cubed? It is 8. Good. So what's the opposite of 2? So if we plugged in a negative 2, we wanted to find or obtain f of negative 2. Now negative 2 cubed, then what do I get? Yeah, I don't get the same back. I don't get 8, but I get the opposite. I get negative 8. This is an odd function. All right? So whether you need this or not, if you think about it, when you plug opposite values in, if you get the exact same thing back, it's an even function. Exact, even, we'll start with the letter E, right? If you plug opposite values in and you get the opposite back, it's an odd function that happens to be symmetric to the origin. So that letter O keeps on showing up there quite a few times. All right, let's go ahead and try a couple of examples here. The instructions say to determine if the function is odd, even, or neither, then describe the symmetry. All right, so if you're looking for f of x, there it is. That is f of x. That's what it looks like. So could we now figure out the opposite? So f of negative x. Think about what that's going to look like. My function is x cubed minus x. But everywhere I see an x, I'm going to put a negative x in its place. So as we're cleaning this up, you have a negative base to an odd power. So negative x to the third power. It's going to be negative, isn't it? Negative x cubed. Minus negative x becomes plus x. Now, look at where we started at f of x. Look at where we finished with f of negative x. Are these the exact same? No. So even is tossed out. It's not even. Are they opposite values? Did we get the exact opposite? Yes, we know it's the exact opposite because all of the signs are different. If you needed to go one step further, an odd function, or opposite values, I should say, In this case, odd functions. But opposite values means that I could factor a -1 out. And if I did exactly that, factored a -1, then I would be left with that x cubed minus x that we started with over here. If you wanted to, I think that a lot of us could go directly from what I have underlined in red and we could say, oh, opposite functions. But what really matters is once we recognize that when I plug the opposites in, I got the opposites back out, this is an odd function. Now, we don't need to see a picture, but what do we know about the symmetry right now? Yeah, it's going to be symmetric to the origin. All right, guys, any questions how we handled that one? All right, let's try this again with the second example, B. H of x is equal to, they just gave it to us, x squared plus 1. So what we want to do is go off to the side and figure out h of negative x, purple, h of negative x like this. So x squared plus 1, but in place of x, we put negative x. So we clean this up, negative x squared is x squared. That plus 1 is quite literally unfazed. So now, h of negative x, we wound up here at x squared plus 1. We started with h of x as x squared plus 1. Are they the exact same? Yes, exact same. Therefore, this is going to be an even function. How would we describe the symmetry? Symmetric to the y-axis. All right, but guys, like I had mentioned at the start, remember, excuse me, that not all functions are going to be odd nor even. A was the first one, f of x, that was an odd function. H of x down there, that was an even function. No big deal. I'm just going to make one up here as I go. Let's call this, I don't know, r of x. If you want to add this, great. If you just want to watch, that's great too. Let's think about x cubed plus x squared minus 7. Okay, so thinking about what this is going to look like, exact same as before. If we went with r of negative x, let's see, we want to fill in x cubed plus x squared minus 7. Everywhere that we see an x, we put a negative x. As we clean this up, negative x cubed becomes negative x cubed. Negative x squared is going to be x squared minus 7. All right, now, how does this compare to what we started with? Are they the exact same? No. This first one is positive x cubed. That one down there is a negative x cubed. They're not the exact same. But are they exact opposites? Also not opposites. If they were truly opposites, then every value, every term would have different signs or opposite signs, and that's not the case. We have one that's different, two that are the same. However we look at it, that's going to be neither odd nor even. No symmetry. All right? Guys, how do we feel about the odd-even business? Is that something that you've seen before, talked about a little bit in Algebra 2 last year? Sounding familiar? I couldn't get a good vibe from 5th period. Some students were like, yeah, I think we talked about that. Other students were like, never heard of it, don't know what you're talking about. But either way, that's how that's going to go this year. I opted, I didn't really make a big deal about it at all. I just jumped in and started doing the problems. Do you suppose, could we have also just plugged in values? Do you suppose I could have gone up here like we did on the previous slide and said, all right, let's let x equal 3, see what we get. Now let's let x equal negative 3, see what we get. And then compare, did we get the same? Did we get opposites? Did we, neither one? We could do it like that if you'd like as well. Okay? All right. Any last minute questions on even and odd? All right, let me stop this.